Hello everybody, this is 19.3. We are interpreting vertex form and standard form. Our essential question is how can you change the vertex form of a quadratic function to standard form? And there's a little more to it than that, but that's an awesome question to answer. Alright, so you don't have to write this one in your notes. Just please take a look at this. Remember standard form is the one that we used when we solved our quadratics, when we used the quadratic formula. And notice the x is squared, right? That makes it a quadratic. We also call them a parabola, and of course that's what they look like, just a refresher. Okay. So this first problem, we're going to determine whether the function represented by each equation is quadratic, and if it is, we are going to sketch a graph of it. Well, hopefully you recognize that this one is quadratic because it has an x squared, and nothing else is squared. We do have a y, right? Nothing else is squared that makes it a quadratic. So first, in order to graph it, we need to get it in our standard form. So we want y equals, so I'm going to move everything away from y. So I'm going to add the 4x, and I'm also going to subtract the x squared from both sides. Okay, when I do that, I will get, I'm not going to worry about this right here because I'm going to change it. I'm going to have y equals, I'm going to write the x term, the x squared term first, negative x squared plus 4x. We have no constant, so that's it. Okay, no c term this time, right? We have an a, which is -1, b is 4, and c is 0. All right, in order to graph this, we are going to need to first find the axis of symmetry. Okay, remember the axis of symmetry is x equals -b over 2a, and I think underneath this is where I did it. Okay, oh, I already wrote it there. It's x equals -b over 2a. All right, so I'm plugging in -4 for the b, well, -b, and 2 times -1, and that will equal a +2. So our axis of symmetry is x equals 2. All right, so that is part of our table. Trying to remember what I wrote here. So let's see. Here's my table. Pull this guy out of the way. My table, I put the 2 in here in the table, right, because that's my axis of symmetry. And how did I get the 4? Well, I plugged in my axis of symmetry to find what y equals, and y equals 4. Okay, then, what does this one say? Oh, the vertex is 2, 4, you guys know that. And then, of course, you want to use numbers around 2, so 1 and 0 I went with up here, 1 and 0, and then 3 and 4. And we're just going to go ahead and plug in those numbers to get our corresponding y's. And I didn't show the work for that, but you guys know how to do that hopefully by now. You're just plugging in each x to get each y. So once I have those, I can sketch myself a graph. This thing keeps getting in my way. So if I start with, on my sketch right here, I'll have 0, 0. I'm going to use a different color so you can see it better. You can put your sketch wherever you want to. There's 0, 0. We have 1, 3. 1, 3, we'll call it there. 2, 4, call it there. 3, 3. And 4, 0, something like that. And it's a curve, right? If you wanted to use graph paper, you could. We know it's going downhill or down, it's a sad base, because a is negative. A is negative. All right, let's do another one. Is this one quadratic? Again, it's getting in my way. Well, if I put it in standard form, get y equals, let's see, subtract the x, 2y equals 13x plus 6, and divide everything by 2. That's not quadratic at all, that's linear. Okay, nothing is squared. So if it's not quadratic, we are not going to sketch a graph of it. That's what it will look like in your homework. And of course, this should go in your notes, how to tell if something is quadratic. From a graph, you should have that U shape. You can pause the video if you need to. And from an equation, we want a to not be 0 because we want the x squared term here. We want x squared, so the highest power must be 2, and you cannot have both being squared. In fact, we're going to take a look at that in a minute. So pause that if you need to. And go ahead and see if you can answer these questions. Pause the video, tell me if it's quadratic. All right, number 1, I'm going to say yes, it's quadratic because we have x squared and nothing else is squared. I don't believe you have to explain why on H or W, you just have to tell me if it's quadratic or not. But this is for your notes. Number 2, this one is not quadratic because nothing is squared. Okay. Let's go ahead and take a look at a graph when y is squared instead of x. And Desmos.com, you can just type in that part right there, Desmos.com, will get you to this website. It's a great website to use to just quickly see things, not for cheating. So we're going to go ahead and plug in x equals y squared plus 3. So x, I'm going to type that in. X equals y, you use the caret button to do squared, plus, what did I say, 3? Okay, so when y is squared, I did tell you guys yesterday, it is a sideways parabola. It is still quadratic, although it's no longer a function, because if you remember the vertical line test, it hits in 2 spots, but it is quadratic. The other thing I wanted to show you is what happens if we square both of them. This is kind of cool. If we square both, so we have x squared plus 4y squared equals 17. So let's see. X squared plus 4y squared equals 17. It is a circle. So when both things are squared, you get a circle. Pretty neat. Okay, finishing this lesson here. Changing from vertex to standard form, please take a second and write that down. Pause the video if you need to. All you're going to do is simplify it. So we need to first get rid of the squared. So we know that it's x minus 6 times x minus 6. And of course, when you multiply here, only multiply 2 together first, and then take that product and multiply it to the other stuff. So this is 4x minus 24, and now that product has to be multiplied to x minus 6, and then of course I will add 3 at the end. So if I distribute, I'm going to get 4x squared over here, negative 24x, another negative 24x, and the last one is a positive 144. And we're going to, of course, add the 3 to that. Let's combine our like terms. We get 4x squared minus 48x plus 147. That's all you did. That's how you get it to standard form. We have an A, B, and a C now. Of course, this is y equals. All right, try this one on your own. Pause the video. Okay, so we are going to get rid of the squared, and you're going to distribute. So we have negative 3x minus 6. That product gets multiplied to x plus 2, and then we'll subtract a 1. We get a negative 3x squared, negative 6x, another negative 6x. It won't always happen that way. And a negative 12, and then minus 1 at the end. Combining like terms. And it's y equals. Okay. All right. If you have your highlighters handy here, this is good. We are going to find the vertex, which is, remember, the turning point. And we'll just sketch a graph. You don't have to do this. I'm just sketching a graph for you. So you see the vertex is where it turns. So we're going to look at the y values. The y values on one end are going to be going down, and then on the other side of it, it's going to be going up. So we're just looking for where the y changes direction, basically. So here we have 9 going down to 1, going down to 0, but now we're switching direction and going up. So the turning point is right here. And you can also see that it mirrors on either side, 1 and 1, 9 and 9. So easy from a table to detect the vertex. Not always in the middle of the table when they give you one, so just pay attention here for the second one. Look at the y's. We are going, let's see, uphill, but then it goes the opposite direction from 144 to 128 is down, down, down. So the turning point, the one where it mirrors on either side, is this guy, okay? Because then you have the 128 matching with the 128, and if you kept going down on your x values, you would see that an 80 would go to an 80, and so forth. So just look for that turning point in the table. So we are going to now write a quadratic function given a table. Always take a minute and write these things down, don't forget. So what you want to do is you want to find your vertex, obviously, and then plug it into the equation. And then you have to plug in another point to find the a. So let's do that first. Let's start off with finding our vertex, our hk. From a table, our vertex, hopefully you guys see it, is this right here, because that's where it changes direction, right? And we have mirror on either end. So the vertex, my hk, is negative 3, 0. Okay, if I were to plug that into the equation, and of course you know the vertex form of an equation is y equals, it's right here, y equals a times x minus h squared plus k. So write that down and go ahead and plug in h and k. Pause the video. Okay, when I plug in h and k, it should look like that. Don't forget, since h is negative, this is going to end up being a times x plus 3 squared, and I don't need anything else. The plus 0 can just be left off. So far I have that, and of course it's y equals, I already forget what was here. All right, yeah, so we want to plug in a point to find a. So we can't use the vertex, but we can use any other point, and I decided to use the first one, negative 6 and 9. So I'm going to plug that in for the x and the y. So when I plug that in, let's see, there it is. Obviously pause the video, and now we can just solve for a. So we're going to have 9 equals a times negative 3 squared. Let's see, that's going to be a times, well, 9. Negative 3 squared is 9. I'm going to rewrite this as 9a. That might make a little more sense for you. And we're going to divide by 9 to get a. So a equals 1. Therefore, our equation, our function, is going to be, I'm just going to hold it up here so I can see, we have y equals, a is 1, so since it's multiplication, I can just leave it off. X plus 3 squared, and again, the k is plus 0. So this is fine. If you put in the 1 and the plus 0, that's fine too. Let's do another one like that. Pause the video, see if you can do it on your own. Alright, it looks like this time my vertex is in the middle of the table. Again, not always in the middle. So my vertex, my h, comma, k, is -2, -3. If I write down my whole formula here, it is good to write it down every time to help you remember. I'm going to go ahead and plug in h and k. X minus -2 would make it x plus 2 squared, and -3 is the k. And now pick any other point to plug in for y and x, and I usually just end up picking the first point. It really doesn't matter which point you use. So I'm going to go ahead and plug in 13 for y and 0 for x. So this is going to be 2 squared is 4. I'm going to write this as 4a just to skip a step here. 4a. Alright, and then just solve for a. Once you have your a, you know what your equation is going to be. I'm just going to write it on the side again here. You have y equals, the a is 4 times x minus h, which comes out to be x plus 2 squared plus k, which is a -3. Okay. You're also going to see these as word problems. So a word problem, we're going to do the same thing. It says the graph of a parabola can be used to determine the corresponding function. Use each graph to find an equation for f of t. Alright, it says a rock is knocked off a cliff into the water far below. Before I go on, you don't have to write down the whole thing. You can just sketch a graph of this thing. That's fine. You can write down it is example for B in case you wanted to go see it later in the book. Alright, so anyways, we have a rock is knocked off of a cliff into the water far below. The falling rock's height above the water in feet is given by the function of the form f of t equals a times t minus h squared plus k, where t is time in seconds after the rock begins to fall. So the important thing obviously is this graph. Just you can sketch a graph of that. And we need to use the vertex and another point, which they give us. Here's the vertex, and here's our second point to find the function. Alright, so I have hk. It's right here, right? H and k. So we have 0, 40. And that can be plugged in. By the way, you can skip steps and do this all in one if you want, but I'm going to do it out separately for anybody that gets confused. We have t in this case. Do use t in HRW instead of x if it uses t, please. T minus 0 squared plus 40. Okay, now we're going to go ahead and plug in the other point for the x and the y. So this is 24 equals a times, oh, this is the t actually, sorry, t. 1 minus 0. So this is just 24 equals, well, 1 minus 0 is 1, and 1 squared is still 1. This is 1a plus 40, and subtract 40. This is a -16 equals a. Ooh, We've seen this before, negative 16. All right, so it's y equals negative 16 t, well, it's t minus 0. I'm going to do it like this for a minute. And what was it, plus 40? Plus 40. Okay, and squared. But that can also be written like this, and I'm assuming if it has a 0 inside here, that HRW wants you to write it like this, but I'm not positive. Because t minus 0 is just t, and t squared is that. So try either one of those for HRW. Last one. Same thing with this one. We want to find the equation, and then we want to estimate. So a ball is thrown off a bridge. The table relates the height of the ball above the ground in feet to the time in seconds after it was thrown. Use the data to write an equation to model in vertex form and convert it to standard form. So this time we're going to put it in vertex form, but we're also going to convert it to standard form, and then we're going to use the model to find the height of the ball at 1.5 seconds. All right, so first of all, finding the vertex, the turning point. This is the one we've already seen. Okay. Turning point is there, so I'm going to go ahead and plug everything in this time. Okay, I'm going to write the formula first, so everybody remembers what it looks like. This is t this time. It doesn't say. So I'm going to use x minus h squared plus k, and I'm going to plug in everything. I'm going to plug in my h and k. This is my h, this is my k, and I'm going to plug in this for x and y. So I have 128 equals a times 0 minus 1 squared plus 144. Plugged in everything at once. So we have 128 equals a times negative 1 squared is 144. And of course, negative 1 squared is 1, so this is just 128 equals 1a plus 144. Subtract your 144. We get our negative 16 again. Okay, so negative 16 is our A, so our vertex form, because they want us to do a couple of things here, vertex form looks like this, negative 16 times, we'll just use x because I don't know if it says t. Again, if it says t, please use t. X minus 1 squared plus 144. Remember, you leave the x and y's as variables. Everything else is numbers. So that's vertex form. They wanted us to also change that to standard form. So let's write that out. That's going to be negative 16 times x minus 1 times x minus 1. Good practice on foiling here. I have negative 16x plus 16 being multiplied to x minus 1. Okay, that's a negative 16x squared plus 16x plus another 16x minus 16 plus 144. Combining like terms, we have minus 144 minus 16 is 120. Okay, so that is our standard form. Again, use t if they want you to use t. And the last part was to estimate or use the model to find the height of the ball at 1.5 seconds. So if the x is the time in seconds, I can just plug in 1.5 for x. Okay, so let's 1.5 squared is 2.25 times negative 16 is going to give me a negative 36. And 32 times 1.5 is 48. And answer is going to be, let's see, minus 36. The height of the ball is going to be, looks like negative 116 units, let's see, feet. And why is it negative? Because it's thrown off a bridge. So below the ground level, I guess. So I'm going to say feet. All right, so your homework is HRW and a couple problems on the review. We will review tomorrow, and the test is on Friday.